Hello, everyone, and welcome to today's live demo. We have a fantastic live demo for you today. So some really cool stuff, nice and technical, but also showing how easy NetScaler is to deploy. So today we're going to talk about automation and Terraform. So we have an action-packed agenda for you. We're going to have Konstantinos who's going to run through the agenda for us, and then we have Rohit, who has a really excellent demo where he's going to step through the nuts and bolts of deploying a configuration of Terraform, and I'm going to push that out and show us it working in real life. First of all, I will ask Konstantinos to take away the show.
Hello all. My name is Konstantinos Kaltsas. I'm the lead product manager for NetScaler Automation Toolkit and APIs. And I'm really happy to be here again talking to you about how you can use NetScaler as part of your DevOps pipelines. So what is the agenda for today? We are going to cover, let's say, our live session in two parts. In the first part, we are going to talk about some general, let's say, common automation flows that we are seeing from our customers. And we are going to talk also about some common considerations and how you can tackle these, let's say, different considerations. On the second part, we are going to have our demo, where we are going to show you how you can use Terraform Cloud and how you can set up a NetScaler automation pipeline using the Terraform Cloud. In this part, we are going also to cover some of these considerations and how you can use Terraform Cloud to tackle the different, let's say, security considerations or other considerations that we are going to revisit. So, but before that, for those that are attending, let's say, one of our automation live sessions for the first time, I want to give a reminder of what NetScaler Automation Toolkit is and why you should care about the NetScaler Automation Toolkit. So we are talking about several different integrations that we are offering so that you can also follow DevOps practices for network infrastructure. So whenever you hear the terms of automation configuration, continuous configuration, or DevOps infrastructure as code, things like that, you can reach out to us through the email that you can see on the screen, or you can access our GitHub repository where all of the information around the NetScaler Automation Toolkit are available there. You can just also scan with your phone the QR code on the top right of the screen, and you will redirect it to our GitHub repository. So when talking about automation, what we are trying to do is to give you a way so that you can automate every day zero to day n operation using either declarative templates or APIs. So as you can see here on the screen, all things from provisioning till upscaling and upgrades are 100% supported both with Terraform and Ansible. And in addition to that, when we are talking about provisioning, we are also providing support for public cloud native templates like CloudFormation templates, ARM templates when talking about Azure, or Google Deployment Manager templates. On the last part, that is not part, let's say, of the provisioning and the configuration part, you would certainly need a way also to monitor your NetScalers, your instances, or monitor all things related to your applications. So for this part, this is something that is supported only through APIs and our SDKs. And in addition to that, we are also offering several different observability integrations that we have, let's say, documentation for that. And we have already done in the past several live sessions around observability. So having said that, let's focus on the topic that we are going to cover today. So what I'm sharing here on the screen is a typical automation flow that we are seeing from our customers. So some things from this automation flow. What you can see on the left side of the screen is that, and this is why, let's say, automation is really important. Usually, the customers that want to do automation are not using infrastructure as code to configure a single, let's say, NetScaler appliance. It would be multiple different appliances that deployed on different environments, like a development environment, a UAT environment, a production environment. So basically, what our customers are trying to do is to create a full end-to-end automation, let's say, strategy that is going to be applied on all different environments and for each one of the different NetScaler appliances. But let's take a step back. So usually how this works is that our customers want to reuse the CI/CD tools that have already in place. So in the same way that a developer is writing an application code and storing the application code on a Git repository, it might be GitHub, it might be GitLab, Bitbucket, or some other, let's say, Git repository. In the same way, we are seeing platform engineering teams or automation teams or DevOps engineers. There are different teams in each one of the organizations with whom we are working that are going to store their infrastructure as code in a Git repository. And apart from that, they want also to follow a similar practices as they are doing for applications. That means that whenever code is going to be committed on the Git repository, there will be someone there to review this code, either from let's say, best practices perspective, or let's say to follow the security guidelines, or several things like that. Again, it depends on how each one of the organizations are working. And this is why, let's say, a solution like Terraform Cloud is important. Usually, customers want to have a single solution to also orchestrate what really happens when we are talking about Terraform. So they want to have a single solution to create, let's say, RBAC configuration, to track every job scheduling, to also get some logging, some reporting about anything related to Terraform. So how this will work is that a developer is going to commit the code. Then after committing the code, someone is going to review the code and approve the PR. And after the approve is going to take place, Terraform Apply is going to be executed from Terraform Cloud. And this is where Terraform Cloud is going to start applying this configuration in the different NetScalers. It might be a NetScaler on a development environment, or a UAT, or a production one. So this is what we are more and more seeing from our customer base. Of course, there are certain considerations when it comes to that, and this is what I would like also to share some more details. When working with Terraform, you are typically working with different Terraform files. So if you are already working with Terraform, you should have already seen TF files, TF-var files, TF state, and things like that. So there are some considerations about how you are going to handle the sensitive informations that are contained in these files, how you are going to safely store the sensitive TF files, how the teams are going to collaborate on the same environment, or what can be committed on Git and what cannot be committed on Git. And then, of course, there are also some best practices that need to be followed with providers. So some considerations and some best practices. And based on these, we have also created the demo that you are going to see on the second part. So there are certain things that can be stored on Git, on a source control system, because teams need to collaborate, need to do versioning, need to follow agile and DevOps practices. And they also need to use the exact same versions when it comes to a single provider. Let's say a team is using our NetScaler provider. So every time that, say, an engineer is going to work with our provider, he or she needs to use the same version again. So the things that you will see here on the screen, like the TF files and the Terraform log files, should and can be stored on the source control. There are also some other tools that are sensitive because they contain, let's say, information that can be sensitive, can't be shared, and things like that. So these files, like the TF-var files and the TF-state files, are files that need to be stored in a way that should be safely stored, should be also locked when someone is doing certain changes, so that the different teams that are working on the same environment will not, let's say, break the configurations that one engineer is trying to apply against another engineer that is already working on this environment. Also, the files themselves need to be encrypted, like the TF-state file contains different sensitive information, and we need also to encrypt this file and safely store these files. But also, apart from that, these files, especially the TF-state file, need to be accessible from Terraform itself. Whenever we are executing a pipeline, this state file should be accessible. So we need to have these files safely stored. These files need to be encrypted, but should be also accessible. One last thing to note here is that, and this is something that we all the time get asked from our customers, is that even when you are encrypting, let's say, a TF-state file, again, the credentials that are part of the TF-state file itself are in plain text. That means that it is a good practice to never store this type of information in a TF-state file itself. So please use solutions like Vault to store your credentials, so you will never have sensitive information in this TF-state file itself. So having said that, these are some considerations that we are going to cover, and these are some things that we are going to see on the demo that Rohit has prepared for us. So having said that, I would like to ask Rohit to share how we are going to leverage Terraform Cloud.
Thanks, Konstantinos. As Konstantinos mentioned, I'll be demonstrating the automation pipeline that we have built as part of this demo. So here in this demo, we are using Terraform Cloud as well as GitHub Actions. So yeah, we hear a lot of customer asking about how can they manage their Terraform state, variables, and credentials. So here today in this demo, we are covering those as part of this. So Terraform state file is an important component of a Terraform. It is one of the advantages of using the Terraform, and it makes sure that the idempotency of a configuration is maintained. Also, the state file contains necessary information that the Terraform requires in the subsequent Terraform runs. Also, the main disadvantage of state file here is that it is a single source of truth for the Terraform to perform. So whenever it gets corrupted or whenever it is mishandled, then there will be chances that the subsequent Terraform runs may fail or complain. So it's necessary for us to maintain and manage the Terraform state file in a secure manner. So for this to perform, we are including Terraform Cloud in this demo. So Terraform Cloud is basically a remote cloud-based service provided by HashiCorp, which is useful in managing Terraform state, variables, credentials, and also in collaborating with the other teammates in the same organization. This is a benefit that is provided by the Terraform Cloud. So let's get to the working part of this demo. So on the screen, you can see the pipeline that is being displayed, and this is a pipeline automation pipeline that we have built as part of this demo. So I'll explain this in detail. Whenever the user pushes a code to this repository, he can create a PR. So whenever he creates a PR, we have written GitHub action in such a way that So this GitHub action will be triggered whenever the user creates a PR. So this GitHub action will be read. So the configuration will be read and it is sent to Terraform Cloud. And Terraform Cloud will perform Terraform plan, and it will send the output of the plan that it is created to the comment section of the PR. So basically, the admin who is reviewing this PR can actually see the plan, and he can view the plan if it if it achieves the target, then only he can approve the PR. Else he can reject the PR, or he can tell the member to make some changes. So basically, we are providing a link of a Terraform plan that is performed in the Terraform Cloud in the comment section of this PR. And whenever the user or admin approves this PR, then only this can be merged to the main branch. So it is one of the policies or configuration that we have did in our repo, wherein it should be reviewed by at least one of the reviewers. So whenever the user merges it after it is being reviewed by the reviewers, so there is another GitHub action that will be triggered. So that will apply the configuration to the NetScaler via Terraform Cloud. So basically, when the Terraform configuration is being applied to the NetScaler, there is a state file generated, and this state file resides inside the Terraform Cloud, and it is well managed and it is secured inside the Terraform Cloud. And this state file is not at all exposed to the local repository or local backend. So basically, this is the advantage of using Terraform Cloud. One of the advantages is managing the state file inside the Terraform Cloud, and also for the Terraform Cloud to authenticate to the NetScaler, we have configured all the credentials inside the Terraform Cloud, so that during the runtime, during the Terraform apply inside the Terraform Cloud, those credentials will be used to configure the NetScaler. Get into the working part of this demo. So in the left-hand side, left-hand side of the browser, I have the empty repository called NetScaler Automation Pipeline with the Terraform Cloud, and it just has two files. One is README, that is documentation file, and .github file will contain the workflow that we have written for this repository. On to the right hand side, I have a VIP. We have provisioned a NetScaler on Azure, and a VIP being displayed here. So the VIP is not currently in action because there is no LB configured with this VIP. In this demo, we have included a small configuration LBB server that is connected to two services in the backend. In this demo, we'll push this configuration to NetScaler, and whenever the NetScaler is configured with this VIP, then we can see the traffic flowing through this VIP, and this will give us some backend information or some server. The server's VIP will be connected to the server with a simple LBB server configuration. So let's create a PR and let's see how the GitHub action is configured, so that the Terraform configuration will be automatically planned by the Terraform Cloud. So let's create a PR, added Terraform configuration to demonstrate LBB server. So here in this PR, I have created some Terraform configuration to configure NetScaler with LBB server configuration. So basically, we are going to create PR for this branch. So let's create a PR. When we create a PR, there is a GitHub action triggered, as I said previously, and it will in the backend will initialize some processes. So example, you can see Terraform plan is being applied in the backend. So another thing here is that whenever we create a PR, it should be reviewed by at least one of the reviewers. So let's assign it to some admin, and here it says the review should be approved. At least one approving review is required by the reviewers. And in the meanwhile, some checks are yet to be completed. Those are nothing but the GitHub actions that are in process. So basically, for this, it is just a PR. So only Terraform plan will be will run for this PR. So here you can see a GitHub Terraform Cloud plan output. So the admin who is reviewing this PR can see this plan, in Terraform Cloud. So he can open the plan, Terraform Cloud, and he can view the plan. And if the plan matches the configuration that the admin wants, then only he can approve the PR, and then later it can be merged to the PR. So this is a Terraform. This is basically Terraform Cloud app.terraform.io, and this contains a plan whatever the user wants to apply to the NetScaler. So after checking and evaluating this plan, the admin needs to approve this PR, and after the approval itself, this can be merged to the main branch. So it is one of the feature from the GitHub that needs to be triggered by the admin of this repo. So let's wait for the reviewers to approve this PR. So whenever this is approved, then it says that changes approved, and then it can then merge to the main branch. So let's merge it to the main branch now. Confirm merge. So basically, the first Terraform action has been applied. That is, a pull request, that is Terraform plan has been performed. So we are merging it to main branch now, and there is another GitHub action written parallelly, which will apply the configuration to the NetScaler via Terraform Cloud. So let's see. So I did initialize the merging part. So here you can see the plan has been applied again, and then we can see the apply is running now, and the apply can be seen here into the details part. So once the apply is done, we can see that the output of the apply will be done here. So let's check the apply configuration, how it is going. Once apply is done, so here you can see Terraform Cloud apply output. So the admin can see the output, or the user can see the output, whatever is being applied to the Terraform. So this is the Terraform Cloud that we are seeing, and we can see the apply output here. 7 resources being added. So whenever we receive some errors, here the error will be displayed here itself. So here in this case we don't see any error. The configuration is fine. So we can see 7 created in the apply as part of apply result. And let's verify this whether the configuration is working or not using this whip. As you can see the services are now active. I'll auto refresh this page. So the LBV server will handle 2 services. So one is a green server, the other is a red server. Here you can see LBV server operating between 2 services that we have configured in the background. So I wanted to show you guys where the Terraform state file will be stored inside the Terraform Cloud. So whenever the apply is done, you can see the comment here, which takes you to the Terraform Cloud. So let's open this link. So app.terraform.io is nothing but Terraform Cloud that we have. So you can see here the apply is finished. So it says 7 resource added, but where is the state file? So here in the left hand side, when you just log in into your account, you can see the state file here, states, and so all the state files will be version controlled, and you can open the latest state, see the state file, and so if you want it locally, then you can download the same and can view the same. That's about the demo. Thank you.
Super. So we had a few questions. hop in there. Sumant or Konstantinos, if there's any you want to take and just re-emphasize or talk a bit more. And
Thanks, Ronan. So first of all, thanks everyone for attending today. We hope we covered several considerations around how you can use Terraform Cloud and follow best practices. There is a question asking if there are any guidelines or standards of whether in which conditions someone should use Terraform or Ansible and things like that. So basically, the main difference between the two is that, of course, both Terraform and Ansible can be used for configuration management, while Terraform can be used also for the provisioning part. But the main difference there is that Terraform is using the state file, as we showed in the demo. So there are all of these considerations about how you're going to store the state file, how to handle all of the sensitive information, these things like that. Ansible doesn't, let's say, work in the same way because you don't really have, let's say, a state file to do all of these things. We are just creating tasks. So it really depends on whether you want, let's say, to have a full state of the overall system, or you want to, create several tasks. It depends on your pipeline. It depends on the whole environment. We can certainly have, let's say, we can certainly plan with our folks from NetScaler community an upcoming discussion about whether and when you can use one versus the other and deep dive into the topic.
Brilliant. So let's move along. So we do have the automation toolkit GitHub repository. So there'll be a link to that coming up. Konstantinos, I think, also had the QR link for that earlier on. So there you will get any automation events we're running. There's a training lab directory, so a list of labs that we have for you. Any blogs that we write will be there. So, and obviously code examples of everything that we've been doing. So this, if you want to do any NetScaler automation at all, this is the one place you should bookmark, go in, have a look. If you can set up any sort of alerts, because we'll be updating that. It's a living directory of automation material that we're providing for you, right? So that is the link down there, github.com/netscaler/automation-toolkit. And then we have tons of things in there for you. Lots of resources. We're doing all we can. If there's anything more that you need, by all means, let us know. So a few little bits of information. If you have never used automation before, you're not, just beginning to look at that journey, how you should work it. We do have a getting started using Terraform here. So this goes into the very, very basics, how to, install Terraform, really, really super easy stuff. Set up some basic LDV servers and services and so on. So that's a really good blog here. And if you're like, well, that sounds good, but I don't have anything to actually do it on, so we have a hands-on lab for you. So come in here, sign up to the community, community.netscaler.com. You can just create an account for yourself, and we've got a hands-on lab here. You can click in and get to work with Terraform and NetScaler, and you'll start using it without having to go and deploy things in your own environment. Lastly, upcoming webinars. And of course, we have all of the previous ones we've done available for you to watch, as we have live demos. So all the previous live demos we've done are also here for you to watch. That's the end of our live demo. So thank you very much, Konstantinos, for the introduction and setting everything up for us, and of course running the automation workshops. Rohit, thank you for a brilliant demo, hands-on, live, configuring it. That's what I love to see. The demo gods smiled on us today. So thanks a million for everyone for joining, and we hope to see you next time.